Hello there. So in today's video we're talking about traits, which is a much awaited topic because I feel like we've referenced it several times. Actually, we've referenced it in, I believe, the last video of generics, in which we encountered a problem. So we had this function called largest, which used a generic to find the largest value in a list. Okay. And of course, initially we tried with I32s and with characters, and it worked just fine. But when we try to implement it with a generic type, let me just uncomment this, we'll see that we'll get an error here saying that t might need a bound for partial ORed. And I told you this was a trait, and we'll fix it in the next video. So here we are. Let's fix it. This is the motivation for this video. First things first, let's learn how to define a trait. I think you'll find this pretty straightforward. We'll just say trait. And for the purposes of this video, I'll call it summary. And now the important part is its body. So you might know traits from other programming languages as interfaces. So in here, we'll define functions that we would like to implement in certain types. And we'll just define the function signature for now. So I'll say function, say summarize, which will take self and returns a string. Now instead of implementing the body, you'll see here that I just put a semicolon. So when we implement this trait in a type, we'll then we'll define the body of this function. Okay, so that's how you define a trait. So if what I said sounded a bit cryptic, don't worry, let's actually implement the trait and you'll see what I mean. So I'll create, first of all, a struct. I'll call it tweet. In here I'll have a user, which will be a string, content, which will be another string, a reply to identify if the tweet is a reply, which is a boolean, and retweet, which will also be a boolean to identify if it's a retweet. Okay, now that we have this tweet, say that I wanted to implement summary for this tweet. I sort of just spoiled the syntax because that's literally it. We say implement summary for tweet. And it works just like that. But now you'll see that we get an error. It's saying not all trait items implemented, missing summarize. So in here, we have to actually define what we had here. So this function summarize. So let's say function summarize, again, references self, so we keep the exact same signature, returns a string, and let's use a format macros just so it looks nice. And we'll say self dot username and self dot content. Okay, and we'll call that our summarize. Oops, we don't want the semicolon. And that's how you implement traits for types. Now I added a note here so I wouldn't forget. We can only implement traits for local types. So if I wanted to implement summary for, say, I don't know, vectors, I can't. And this is a design choice so that people wouldn't mess up external code with their own code. Okay. So yeah, that's about it for implementing traits. Now the main takeaway of this video is how to use traits with functions. And to start off, let's talk about traits as parameters. There's several ways to do this. I'll code them and then I'll go over them one by one. So I'll be back. So as you can see, there's a lot of ways to do this, but I figured it was important to show all of them so that when you're reading code, you can also understand it, even if you have a personal preference to use one of these. The first one, we're passing item, and this item will be in, well, implementation summary. And what this means is that here we can receive any type that implements summary. So say that before I had tweet and I had a news article, and both of them implement summary. Both of them could be passed in as parameters for this notify function. And then in here we just call summarize because they'll all have this method. They're guaranteed because they have this trait. Now in here we're defining a generic T which implements summary, and we're just using it. Same idea. And in here we're just saying a generic T. This will be of type T, where T implements summary. And each one of these methods, they sort of serve their own purpose. This is the simplest one, in my opinion. But if you start having several of these, so say item 2, implement summary, it can start getting messy. Or even if you want to add more, I guess, trait bounds, you could say item 2 T. Now what this means is that you want to have a type that implements summary, but item and item 2 must be of the same type. So say in here I can pass in tweet and I can pass in news article, but in here I have to pass in tweet both times. And I'm saying news article, but news article is just say another struct, just like tweet. And then in here, say that you have several generics, so you have T, which implements summary, or I don't know, a bunch of stuff. It can get messy, it can get sort of confusing to read. So in here you can just say, or here in the same line, you say comma, U summary, and it looks a bit better. Okay, so yeah, that's the general gist of it. Once again, you're free to use any of them the best way that they apply to your code. So that's traits as parameters. Now, talking about returning traits is sort of the same idea. We can have a function, say return summarizable, and in here, let's not pass in anything, and we'll just say implementation summary. And then you have your code. So what this means, again, is just this function will return any type that implements summary. But one important thing I want to point out here is that we can only return one type. Okay, so say once again, actually, I keep on referring to this news article. I'll just code it real quick so we can have actual something to look at. I'll be back. Okay, so when I mentioned news article, this is what I meant. So it's a struct with whatever, and it just implements summary as well. So say in here, what I was saying is that return summarizable can only return one type. So we can't say we have a parameter called switch, which is a boolean, and in here we say if switch, we return a news article with with stuff in it. Say okay, and then in here we had an else, which then returns a tweet. Now I don't even remember what tweet had. Their username. I'll just copy this, paste it down here, and then okay, false. We can't have two different types be returned. You see that we get an error saying if and else have incompatible types. And we'll learn how to get around this later on. So till then. But yeah, this is useful now in terms of closure and iterators, which we'll talk about later. So yeah, that's returning traits. Let me just comment this out. That's how you do it. Oops, that should be a toString. Okay, so as I was coding news article, I remember that I forgot to talk about something. So say that I didn't want to implement this summarize function for news article. I just wanted something right out of the box. For that, we use something called, let's go back up here, default implementations. Okay, so what traits also allow us to do is instead of a semicolon, we can actually define a body. So we can say something like format, or not even format, let's just say read more. Yeah, and then return it to string. And in here, so say, hopefully this shouldn't have any errors. Mismatched types found, oops, semicolon. Okay, now say what this allows us to do is that if we go back down to our news article, I can just remove this and do this. So implement summary for news article. This way, if we call the summarize method on a news article, we'll just get read more. Okay, so that's default implementations. Okay, so I promised that I'll try to make videos not as long, and this video is getting a bit long, so just to save us some time, I copied this example from the Rust-Lang programming book, and this will display us how to use traits to conditionally implement methods. And what that means is that we can implement methods only if the type that we have implements certain, well, traits. Okay. So in here, we just have a struct called pair, which is an x of t and a y of t. And now we always implement this. So for any type t, we implemented this new function. But now in here, and now there's some new syntax, we only implement t for types that implement display and, so pay attention to the plus, and partial OR. Okay? And then we implement just this method that checks if x is larger than y and returns this, and if else it returns this. So yeah, we can use traits to conditionally implement methods. So if we were to call this method compare display on something that doesn't implement these, then you wouldn't find it. So it's not implemented for that type. Okay. Which is, once again, another display of why we want several implements. Okay, so yeah, now to finish off, let's go back to our motivation and actually make it work. Okay, so I scroll right back to the top and let's actually fix our problem. So let's uncomment this. Let's look again at the error. It says that t might need a bound for partial OR. So what we can say is we can just say that t implements partial OR. And that's all good, but we get another set of errors. We say that t cannot move out of type t in a non-copy slice. Now, if you remember back from when I taught you ownership and references and all that, types that have a set size, like I32 or characters, are stored in the stack, and they implement a trait called copy, which means that doing this, we don't lose ownership, and we're just copying it onto the largest. But if we do have a dynamic size, we can't do that, and instead we lose the reference. So there's several ways to fix this. One of them is pretty straightforward. We can just say that it's a t implements partial OR and copy. So it implements these two traits, and then it works right out of the box. If we don't want to restrict it to copy, we can then say clone, which then specifies that it can be of dynamic size. But then again, of course, we get these errors, so we can just say instead .clone and .clone. That should work just fine. Or instead, if we don't want to restrict it at all, then we can remove this, and instead we can return a reference, right? And then in here we just change it all to be references. So instead we're getting a reference of this list item, and in here we're comparing a reference. And that also works. So yeah, experiment, do whatever is best for you. And that'll be about it for the video. Thank you so much for watching, and I'll see you next time. Bye bye.